Alright, so what we're looking at with this new lesson is what are called inscribed angles. Before we can talk about those, I have a new term for you. Chord. A chord is a segment whose endpoints are on the circle. So if we look at AB here, AB is a chord because the endpoints land on the circle. So chords can have all different types of measurement. When I think of chord, I kind of think of like the strings on a banjo. Those would all be chords. So they can be shorter, they can be longer, but they can have all different kinds of measurement. An inscribed angle then is any angle whose vertex is on the circle, so the vertex has to be on the circle, and then the sides end up being chords. So this DEF, that's your inscribed angle. And then the second term here, intercepted arc, is the arc that is on the interior of that angle. So arc DF here is called the intercepted arc. And the next thing we want to look at is what the relationship is between the inscribed angle and the intercepted arc. So if you think back to a couple chapters ago, when we found this central angle here, we knew that that's equal to whatever the arc is, so that would be 60 degrees. But if I want to find the inscribed angle, if you notice here, that one goes a little bit further out, it gets a little bit smaller, it's stretched out a little bit more. If we are in class right now, I'd ask you, well, how much do you think it gets smaller by? And I think most of you would agree with me that it gets smaller by half. So that actually ends up being 30 degrees. So what that tells us is the inscribed angle is equal to half of the intercepted arc. So then I have a couple of examples here for you to look at. So what's the key to remember here is when you're trying to find the angle is getting smaller. So I'm trying to find the angle here, so I have to take half of 200 to find the angle because it's going to get smaller. X ends up being 100 degrees. But when you're trying to find the arc, like in number 2 here, the arc is actually the bigger thing. So to find x in this one, you have to take the angle and multiply it by 2 to get the arc. The arc is 70 degrees. And then number 3 just gets a little bit more complicated. We actually have to first find the arc that's missing here, and you have to go back to a couple chapters ago. We can do 170 plus 60, which is 230. And hopefully you remember the whole circle is 360. I can do 360 minus 230. That ends up being 130. So x is 130. And then to find y is this angle. So to find the angle, that's the smaller part, I have to take half of 130. Y ends up being 65. The next part we have here are some corollaries to what we talked about. So the first corollary has to do with if two inscribed angles, so if I look at angle A and angle B, if they intercept the same arc, which these two do, they intercept that arc, then the angles themselves are congruent. So you wouldn't even need to know what the arc is. You would automatically know they're congruent. So if you look down at example number 4, if I want to find x intercepts that arc. The 28 they gave me also intercepts that same arc, so without doing any work, I can just say x is 28. You don't have to do the doubling and dividing by 2 because you're going to end up with right back at 28. In corollary number 2, they tell you that if an angle inscribed in a semicircle, then it's a right angle. So what this really tells us is if you find a triangle that's in exactly half the circle, you automatically know it's a right triangle, because this is going to be half of 180, which is 90. So if you look at number 5, below it, we have this triangle, which is taking up exactly half the circle. I automatically know that's a right angle. So to find the missing angle, I can do 15 plus 90, which is 105. Subtract from 180, x ends up being 75. And then for number 6, we go to corollary number 3. It says, I'm going to zoom in on this one, it says that the opposite angles of a quadrilateral that's been inscribed in a circle are supplementary. So when it says opposites, that means A and C. A plus C has to be supplementary is 180. And then B plus D has to also be 180. So your opposite angles have to be 180 in a quadrilateral. So if you look at number 6, to find angle x is going to go with 57. They're not equal to each other. They are 180. So I'm going to do 180 minus 57. I get 123. That's my answer for x. Then to find y, I pair it with 85. Those are 180. So I do 180 minus 85. I get 95, and that's y. The last new concept we have to look at is what's called the tangent chord relationship. So these look a little different because you have a chord and you have this outside thing, but the vertex is still on the circle. You have a chord and you have this outside thing, but the vertex is still on the circle. So since the vertex is still on the circle, even though it doesn't look like an inscribed angle, it still has the same relationship. The angle is equal to half of the arc. So in this example, if I want to find angle W here, angle W intercepts this arc, so I just have to take half of it. Half of 246 means angle W is going to be 123. And then all I've done for you next here is come up with some varied examples to kind of test everything that I gave you in the notes. So if I want to find angle A, the first thing I do is I trace angle A, so I can kind of get an idea of where that's going and find the arc that's inside of it. To find angle A, I just have to take half of 108, which means angle A is 54 degrees. To find angle B, again, if you trace it, I like to trace the angles because it gives me some perspective for them. That intercepts the 60, so angle B is just half of 60, which is 30. And then your tricky one here is C, because if I trace C, I don't know that arc. What you really need to reference with C is that C is the same as this. I can use this triangle. I knew A was 54 and B was 30. So if I use that triangle, remember a triangle is 180, I can do 180 minus 54 plus 30 is 84. That's 96. So C ends up being 96 simply by using the triangle. You couldn't actually use the arc there because it wasn't given to you. Number 8. When you look at number 8 right away, you should see that this is a quadrilateral. When you have a quadrilateral in a circle, it's the opposite ones you're worried about, and they're 180. So to find P, I can do 180 minus 90. P is 90. And to find Q, Q goes with the 58. I can do 180 minus 58. That tells me that Q is 122. Number 9. To find X, X intercepts this arc. So I'm going to have to take half of the arc to find the angle. Half of 72 means X is 36. And then to find Y, Y intercepts that same arc, so I don't even need to do math there. It's the same answer, 36. Number 10. When I want to find A, again, the first thing I usually do is trace the angle, but then I get stuck for a second because I don't know A. So then we look at A. A is an arc. Well, I know this other arc here. And you should remember from a couple chapters ago that this is a semicircle that's 180 degrees all the way across. So to find A, I have to do 180 minus 95. A is going to be 85 degrees. To find B, B intercepts the 95 degree arc. So for B, I can take 1/2 of 95. That's 47.5. And then for C, C is in this triangle. This triangle is taking up exactly half the circle, so what that means that this is automatically a right angle. Because what we're doing here, if I make that big, I'm taking half of 180 degrees is the whole semicircle. So C is half of 180, which is 90. You don't have to do that math. You can just look at it and say, since it's a triangle, inside exactly half the circle, it's automatically a right triangle, so C is automatically 90 degrees. Number 11, we have a quadrilateral inside here. So to find angle A, It's actually, if I trace angle A here, oh, that's actually not what I want to do because it has a variable there that's not going to help me. So instead, since it's a quadrilateral, I did say that quadrilaterals have special properties here. I know I want to look at the opposite angles. So to find A, I have to do 180 minus 68. A is 112. To find B, B is an arc. It starts here and ends here. But there's no angle that starts there and ends there, so I can't just use one angle to find that. I have to trace a bigger angle. I can trace this angle because it does stop at the right point, but what it also includes is the 104. So I can find what this whole arc is by using that 112 and doubling it. That whole arc is 224. So to find B, I have to do 224 minus the part I didn't want. I didn't really want the 104, but I had to include it to find B. So B ends up being 120. To find C, it's the same kind of thing. It starts here and ends here, but there's no angle that starts and stops there. So I need to find an angle that I know the measure of that we can break it apart here. So to find the whole arc, I can do 71 times 2. That's 142. And then C is really 142 minus the 104. We don't want that part. And 142 minus 104 means C is 38. Number 12. So actually two different ways to go about number 12 here. I know that this is 230. And I want to find the other side, really is what I'm looking for. I'm looking for the angle and the arc on the other side. So one of the ways you could do this is you could do 360 minus 230 and find y right away. Y is 130. And then once I know that y is 130, if I want to find this angle on this side, that's where the x is. X is this angle. This is on the circle. Anytime it's on the circle, you have to take half. So it's half of 130. X is 65. The other way of doing this was to find this angle first by taking 1/2 of 230. 1/2 of 230 is 115, and then you can do, these make a straight line, they're supplementary. You can do 180 minus 115, you get that x is 65, and then double it to find y is 130. Number 13, we are going to skip A and B here, we're just going to jump right to C. So the point here is that you have a quadrilateral here. So if I want to find C, I want to pair it with the opposite angle. Those are supplementary. So I can do 180 minus 96. C is 84. To find D, I can pair it with the 100. Those are supplementary. So I got to use 180. 180 minus 100 means D is 80. So hopefully when you see the quadrilateral, those should be really easy. You just got to make sure you're using 180 there. Number 14, if I want to find angle, or arc A is an arc, I can trace the angle. So remember your arc is your bigger part, so I don't want to divide, I actually want to multiply here. 25 times 2 gives me A is 50. And then for B, if I trace B here, B is part of this triangle that isn't exactly half the circle, which means automatically B is 90. And if I trace C, C is part of this triangle, which isn't exactly half the circle, which means right away C is also automatically 90. You don't even have to do any math there. And then the last one, number 15, I want to find angle E. This is what I was talking about in number 12 as well. You can use your straight line here. I can just do 180 minus 115. That gets me E is 65. And then find F. F is the arc, so I'm going to have to make it bigger to find the arc. So I need to double 65. F is 130. That's all about inscribed angles. Hopefully these notes will help you to work through your homework. Good luck and have a great day.